Alright, so let's do another example. So I want to find and classify the critical points for x squared plus xy plus y squared. We'll deal with it.
Okay.
So, what do you start with?
Gradient.
Okay, so take the gradient of f. What do you get?
2x plus y. I. And then 2. And then y plus 2y.
X plus 2y.
Oh yeah, x plus 2.
Okay, so we got 2x plus y and x plus 2y. Now what should we do with these?
Set them equal to 0.
We need to set them equal to 0. So we got 2x plus y is 0 and x plus 2y is 0. You guys remember how to solve things like this? 0, 0 is the answer?
No. Multiply the bottom by -2.
Well, we can have more than
Okay. Multiply the bottom by -2.
negative.
So then I've got 2x plus y is 0 and minus 2x minus 4y is 0.
Add them.
Add these. Good. Okay, so you get minus 3y is 0. That tells you y is 0. And then you take that information, right, plug it back up into one of these, figure out x is 0, right? Okay, so 0, 0 is what? Critical point. Okay, now what?
Is it a max or a min?
Yeah, I want to establish whether it's a max or a min. Okay, and kind of the point of this one is that right now I don't know. You guys all see that?
Then would you just do like a change in x by x?
Yeah, I might look at the fxx and fyy, right?
Yeah.
fxx is 2, so that's positive.
Yeah.
fyy is
2.
2.
also 2, positive.
But fxy would still be.
They're all positive.
Yeah, these are both positive, right? So it's concave up in both directions.
And they'll be concave up in the other 2 directions.
So,
Yeah.
what do you mean in the other 2 directions?
The x, y, and the
X,
x.
y.
Those other partials.
Yeah, but keep in mind there's way more than 2 directions,
Yeah.
right? There's way more than even 4 options, right?
Yeah.
So it's not enough for me to establish that these things are up. You guys see that? And I don't have the more robust second derivative test yet, which we'll have in a moment, but we don't have right now. So if I can't figure that out from this, maybe I should try to like complete the square on this thing.
Oh.
Ugh.
But it just,
Well, that would just be.
no.
No, no,
Because it's
no.
not x plus y squared. Because it would be if you had a 2 on the x, y, but you don't.
Yeah, you guys see that? If there was a 2 in here, this would be
Yeah.
the quantity x plus y all squared, right?
Yeah.
Okay, so
Wouldn't it just be
do you guys
x
remember how to try
squared plus y squared minus x?
squared plus y squared minus?
Then you have the quantity and you get you that number.
Say again?
You do the quantity of, what is it, x squared plus y squared, and then you subtract the whole thing by xy.
Oh, okay. So x plus y squared minus xy.
Oh, okay. Yeah.
That's true, right? This piece is positive, I know that. That piece could be negative sometimes, right? So if that piece is negative sometimes, then I'm just not sure, right?
But x plus y squared is always going to be bigger than xy.
X plus y all squared is going to be bigger than x times y.
Except for 1. Well, it'd be 0.
Bigger or equal.
Yeah. It's not going to be less than, so it's not going to, the function's not going to be pointed downward.
Yeah. Stick it.
But if you have negative values,
Yeah, with negative numbers, that's probably a problem.
Well, it'll
But
still
you're
flip it
squaring
and keep it positive.
You're squaring, if you have negative numbers for x
x is -2 and y is -1.
Okay. Let me rephrase this.
Well, then
I have no idea.
Okay.
Okay, and so if I don't know, maybe this is a good time to develop our more robust test.
okay. So. let's
Okay,
start with-
do you guys want me to tell you what the more robust test is and we can try it on this?
Yeah.
Sure.
Okay. So the more robust test is you make this thing called D, that's fxx times fyy, and subtract fxy squared.
Yeah.
Of course, these are all need to be evaluated at the point you're talking about, right? So this is evaluated at the critical point, this is evaluated at the critical point, and this is evaluated at the critical point.
Okay.
Okay. And then if D is bigger than 0, right, that's going to be the analog of concave up, probably,
Yeah.
right? So then that would mean that the CP is a min. I've lied to you.
Maybe calculus.
So if D is bigger than 0, that's enough to establish it's either a max or a min. Where do you go to check? So this is either a min or a max. Check.
Second partial.
Yeah, check either of the second partials, right? Either
Or can't you
fxx or fyy.
Can't you also check the original function to see if geometrically?
Yeah, or we could check geometry, right? Oops, 4. So if this thing's bigger than 0, we've got a min or a max, and we should check the concavity. If it's less than 0, that's going to tell us we've got a, what's the other option if it's not a min or a max?
A saddle.
Saddle. And what if it actually is 0?
Is that like
Inconclusive?
tells us nothing?
Yeah, that's going to be inconclusive. Cool. All right, so can we check this one? So, what am I looking for? I need fxx, fyy.
Yeah.
So fxx is
2.
2.
2, even at the critical point, it's still 2. Fyy is also 2. Fxy is
1.
1.
Yeah.
One.
Yeah, 1.
Okay, so I've got,
2 times 2 minus
4 minus 1 equals 2.
so 4 minus 1 is 3.
And
Cool.
then,
So it's either
but then we also know that fx, x, and fyy are positive. It's a max, right? Or min?
Yeah. Yeah, so it's bigger than 0, which means I'm in the conclusive land, right, of it's either a max or a min. And I know these two guys are both 2, right? They're both positive, so I know it's concave up. That means it's a minimum.
Yeah.
You guys see that? So I found out 0, 0 is a min.
So
Hold on.
fxy is 0, and then your ffx, or your fxx and your fyy are positive, then you can pretty safely say it's
Yeah. Cool? Check?
How,
Yeah.
hang on, how do we get the
Yeah.
2? And then, I'm sorry.
So how to get the 2? So
Just,
this piece is fx, and this one's fy, right? So to get fxx, I need to take the derivative
Oh, it's
with respect to x of this guy. And for fyy, I need the derivative with respect to y of the other guy. So I got 2 out of each of those.
yeah.
And then to get that fxy, I take the fx and take the y derivative of it. You guys see that? So I'll get 1 out of that piece. What was your question, James?
Is there a scenario where fxx is positive or fyy is negative? Like, where one's positive and one's negative?
Yeah. Yeah, that's that saddle.
Oh, okay.
Right, so I know in the case of a saddle, right, you guys notice that if one of these is positive and the other one's negative,
You're always.
yeah, then I'm always getting a saddle, right? It's
Yeah.
definitely negative minus a negative is going to be a negative number. Cool. So really, this is a question about, okay, is the concavity in the x and y direction strong enough to cancel out some kind of change in concavity as I move around?
Okay.
You guys see that?
Mm-hmm.
So that's our, like, okay, it shouldn't matter how I look at this thing. So I should have this, like, if I tip my head, how does that rate change? That's kind of what this guy's doing.
So like the x and y concavities are stronger than the twist.
Yeah, that's really what I'm wondering, right? Is that thing strongly enough concave up to cancel out the twisting that I would have happening from the x and then y?
So why can't you just look at that and know that
But
it's
this
gonna
guy?
yeah, that it's gonna be concave up?
Okay, so can I make one that looks like this, right? So f of x and y looks like x squared and y squared with an xy. Can I fill in a blank here that would cause this to be a saddle?
Oh.
Greater than 2.
Yeah, you guys see that? If I put in a number there like 7 or something, right?
Okay, then that's gonna dominate.
Then that piece will dominate. Really, the twist is overwhelming the concavity, and I get, all of a sudden, it's a saddle.
But without that integer out front of the xy.
Yeah.
In the twist, then you can see that the squares on both the x and y are gonna overpower that center square.
Yeah, and for some reason the critical is at 2, right? You guys see that? With more complicated functions, of course, I can't really play that geometry game as well.
Yeah, but
And so having this test is kind of nice.
Mhm.
But with this one, yeah, we can look at this and we can kind of think to ourselves, okay, these two guys are probably going to dominate.
I didn't mean like having that like that's my answer is because of how it looks, just like, oh, because it looks like this, I think it'll be concave up, and then doing that, just to check it.
Yeah, that's really good intuition, right? Looking at this and saying, okay, this number is pretty small, so probably the ends are going to dominate. Yeah, it's great intuition. Cool.